Hello, I am Tauksik and this is my final project presentation for Data 604. The agenda and flow of the project is something like this: key findings on the raw data, hyperparameter tuning and model selection, kernel PCA analysis, and all the way to conclusion. So this project explores the classification and clustering on the MNIST dataset. First, I analyzed the raw data using SVMs and clustering methods. Then I applied dimensionality reduction using kernel PCA and Laplacian eigenmaps, and finally compared their effects. The key findings on the raw data were: for binary SVM 0 versus 8, the RBF kernel achieved 99.38% accuracy and the linear SVM got 98.58 accuracy. In the 6 class SVM setup, 1 versus 1 gave 95.29%, slightly better than the 1 versus all at 94.28%. In the k-means clustering, for k is equal to 4 to 8, k is equal to 6 produced the best alignment with the true digits. Hierarchical clustering using word linkage correctly recovered around 6 clusters, while the L1 version failed. The outputs are seen on the right side. Hyperparameter tuning and model selection. So the soft margin SVM with different values of C from 0.1 to 100 was tuned. Across all the cases, the best gamma value was 0.01. C is equal to 100 gave the highest validation accuracy at 99.38%. For the multi-class SVMs, 1 versus 1 was selected because it consistently outperformed the 1 versus all. Kernel PCA analysis. So the kernel PCA was applied using an RBF kernel with around 300 components. This reduced dimensionality significantly, but it hurt the classification because the RBF SVM accuracy dropped to 59% and the cluster sizes became imbalanced. For example, k is equal to 6 gave one large cluster of over 31,000 points. So the kernel PCA captured the global trends, and these are the outputs for it. And the dendrograms are representing the Ward plus Euclidean and the average plus L1 Manhattan distance. Laplacian eigenmap analysis. Laplacian eigenmaps was applied with 30 components using a 10 nearest neighbor graph. So k is equal to 10. This embedding nearly restored the raw SVM accuracy by 99% for binary SVM and 98% for the multi-class SVM. Clusters were well balanced with a silhouette score of 0.65, and the computation time dropped by nearly 70%. 30 components gave the best balance overall. The dendrograms show the cut at around 48 using Ward plus Euclidean analysis. So it is seen here. Error analysis. In the binary SVM for 0 versus 8, misclassifications were minimal. So 0 was misclassified as 8 by only about 0.2%, and 8 was misclassified as 0 by about 0.5%. In the multi-class SVM, the top confusion pairs were 3 versus 5, 4 versus 9, and 7 versus 1. So the issues and solutions. There were few technical challenges faced in this project, like KPCA reduced its accuracy, so we had to switch it to Laplacian eigenmaps. The hierarchical clustering was slow, so I had to subsample for 1000 points for the dendrogram. Mini batch k-means was used to manage the memory issues, and L1 linkage created some unbalanced clusters, so I used Ward plus Euclidean distance instead and ran the codes. Clustering process and visuals. K-mean centroids were visualized as a 28 cross 28 digit images. At k equal to 6, these match the digits very clearly. For hierarchical clustering, word linkage gave a clean 6 cluster cut, supported by a visible gap in the dendrogram as seen here. These were how the images of the digits looked, and the corresponding dendrograms are also seen here. To conclude, the Laplacian eigenmaps gave the best trade-offs like high classification accuracy, balanced clusters, and fast computation. KPCA captured broad patterns but reduced the performance. So the dimensionality reduction should match the tasks like using KPCA when supervised clustering is the key, and using Laplacian for strong classification and overall efficiency. Thank you.